A beautiful rosewood chest was acquired by an antique shop in Arlington, Virginia in 1979. It was purchased shortly after by a young lawyer, Robert Hegestad.
As I left the store, I noticed a cabinet behind the counter and asked the dealer if it was for sale, and he said, yes, it was. Would I like to see the contents? And I said, no, not really.
Turns out, this handsome cabinet housed something very special, a window into our understanding of how living things come to be. Once hermetically sealed and kept intact for nearly 2 centuries, 26 drawers labeled A to Z contain pieces of a biological puzzle assembled by 19th century British naturalist and field biologist Alfred Russel Wallace. Wallace today is considered the father of biogeography and co-founder with Charles Darwin of the theory of evolution by natural selection, both building blocks on which modern biological science is based. The cabinet houses his personal collection, specimens found nowhere else.
But really the value of this collection is because it was part of Alfred Russel Wallace's life, and he was such an important figure in evolutionary biology. So the primary value is the history of science.
Wallace was eccentric, extraordinarily curious, an explorer, a pioneer. His letters to Charles Darwin pushed Darwin to publish his seminal book on the origin of species. Wallace had also developed these theories independently from remote jungles and isolated islands all over the world.
He was not a rich person. He didn't come from the aristocracy like Darwin. He collected critters for a living and sold them to museums and scientists.
He kept the best specimens for himself. Housed in his original cabinet are 1,700 specimens, including species then newly discovered and even today found nowhere else and considered new to science. His personal collection includes examples of the world's largest moths, insects so small they had to be glued rather than pinned to labels, British butterflies and moths studied by both Wallace and Darwin as a foundation for natural selection, at least 2 species of butterflies that are now extinct, a firefly he collected in Germany when he was just 11 years old. Years later, Wallace writes with wonder of a firefly in the Amazon.
By moving one over the lines of a newspaper, I was enabled easily to read it.
I think the collection is important and interesting because it connects real organisms with people to show the development of a man, but also the development of these fields that are so important in society today.
This cabinet provides evidence to support this revolutionary scientist's work and theories on evolution. Both Darwin and Wallace cite fireflies as examples of species with protective color, an important component of natural selection that warns away predators.
Glowworms and fireflies belong to uneatable groups that would be liable to be seized and injured, if not devoured, without the warning light, which tells all insect-eating creatures after one experience that they are uneatable.
Specimens in his collection exemplify other elements of natural selection.
I have described a butterfly which, when at rest, so closely resembles a dead leaf that it thereby escapes attacks of its enemies.
Masquerading as parts of the forest keeps some moths safe,
while the buff-tipped moth so contracts its wings that it looks exactly like a thick piece of broken stick, the yellow patch at the extremity of its wings giving the appearance of a freshly broken end.
Mimicry, a similarity of one species to another which protects one or both.
The clear-winged moths resemble bees or wasps.
And edible white British moths resemble their inedible relatives. Wallace documented how populations within a species would vary in different regions because the conditions necessary for survival differ. Similarly, he discovered that if the condition in a singular region changed over time, a species would also change.
This progression, by minute steps in various directions, is always checked and balanced by the necessary conditions subject to which existence may be preserved.
These are the things I think would get kids excited about biology, not only as observers and students, but as collectors themselves.
Wallace was posing questions 150 years ago that we're just now trying to answer.
This cabinet is a time capsule and a hope chest. Its contents provide insights from the past and opportunities for discovery in the future that advance science and human understanding. I'm Lisa Joy Zagorski with the National Science Foundation.